Okay, so we're going to be taking the derivatives of log functions today. Okay, and so we're going to do both natural logs and common logs. So, although I think your worksheet is all natural logs because we don't do a lot of common logs, but just as a refresher, the derivative of natural log of x is 1 over x. And the derivative of log base anything else is 1 over x, and it's similar to the exponentials, but instead of times the natural log of the base, it's divided by the natural log of the base. Okay, but our focus today is going to be on this. Okay, now because the derivative of natural log of x is 1 over x, if I take the derivative of natural log of a function, then my derivative is going to be 1 over, now here's where it is. So the x and the x have to match. So if this is my function, that's got to go here. So 1 over the function times the derivative of the function. Okay, so this is how I usually say it, that the derivative of natural log of stuff, I know this is super technical, is 1 over the stuff times the derivative of the stuff. Okay. So that's how chain rule is going to work. So if I gave you y equals, make this number 1, natural log of x squared plus 2x minus 4, my derivative is just going to be 1 over the stuff times the derivative of the stuff. So 1 over the stuff that was inside is x squared plus 2x minus 4, times the derivative of the stuff, I need parentheses. Okay, and my parentheses inside is going to be the derivative of the stuff. So the derivative of x squared plus 2x minus 4 is 2x plus 2. Now I have some students every year who are like, instead of 1 over the stuff times the derivative of the stuff, they remember the rule as the derivative of the stuff over the stuff. And if that's how you want to think about it, the way that I do that is sort of like if I was on this one, I would do y prime equals, instead of 1 over the stuff, I would do blank over the stuff. And then I would throw the derivative of the stuff right up top. And you guys see how that's this, but it looks a little cuter. So it's sort of like blank over the stuff times the derivative of the stuff, and you could put the derivative of the stuff right up top. If you guys need me to hold on, let me know. So if I have y equals natural log of sine of x, when we go to take the derivative, it's going to be 1 over the stuff times the derivative of the stuff. So 1 over sine of x times the derivative of sine of x is cosine of x. Okay, and we can rewrite it. We don't have to rewrite it. It's cosine x over sine x. If you want to, you can say, oh, wait a second, cosine over sine is cotangent. But that's not at all necessary. Let's do y equals natural log of e to the x minus x squared. You guys try this one. Okay, so I'm going to do, my derivative is going to be 1 over the stuff. So 1 over e to the x minus x squared times the derivative of the stuff. It needs parentheses because it's got multiple terms to it. So e to the x, I'm sorry. What's the derivative of e to the x? E to the x minus the derivative of x squared is 2x. And then I prefer to write it as one single fraction because it just looks like too much chaos otherwise. Okay, so it's this stuff over this stuff. Easy enough, right? Okay, so one thing that's going to come up a lot in these problems that can help you make your life so much easier, and I really, really want to make your life so much easier, is our log rules. So just as a refresher, if I have the natural log of a product, it's the natural log, it's the sum of the natural logs of the pieces. If I have the natural log of a difference, it's the difference of, if I have the natural log of a quotient, I have the difference of the natural logs of the pieces. And if I have natural log of a to the b, I'm allowed to pop the exponent out front, right? And make it b times the natural log of a. Did I ever show you guys this little thing for remembering how to handle your exponents when you're multiplying exponents? Matt? Okay, so I didn't show you guys this. Okay, so this is like a little tricky cheat sheet for how to handle how to handle multiplying exponents, which is not something that you guys generally need help with anymore. But sometimes when we're like all kerfuffled when doing like a long calculus problem, we screw up x squared quantity cubed, right? We're like, oh, x to the fifth instead of x to the sixth because I'm supposed to multiply the exponents. So this is a cheat sheet. So it's PEMDAS, but I put an asterisk because we're doing exponents. Okay, I'm bringing something to a higher power and there's parentheses involved, so I'm going to multiply the exponents. I get x to the sixth. Okay, if I'm doing x squared times x cubed, where I'm multiplying the bases, I look below it and I add the exponents. If I'm doing x to the 10th divided by x to the 7th, where I'm doing division, I subtract the exponents. I get x to the 3rd. Okay, so this is something that I used to do when I used to teach Princeton Review when I had students who like had no clue about the exponent rules. Is everybody following what the heck I'm talking about? That whatever operation you're doing with the bases, you look below it and that letter tells you what to do with the exponents. Well, these work for logs too. So if I have the natural log of a product, it's, right, that's multiplication. Oh, I'm doing the wrong color. It's multiplication. I'm going to add the natural logs of the pieces. If this is helpful, great. If you have no clue what I'm talking about and it's not helpful, then don't stress about it. If I'm dividing inside my natural log, then I look below it and I subtract the natural logs of the pieces. And in this case, P is standing for power. So when I have something to a higher power, I'm going to multiply. So it pops out front and I multiply them. Okay, so if that's a helpful cheat sheet, fantastic. If you have no idea what I'm talking about, don't stress, but you do need to know these basic log rules from pre-calc. Okay. Another really important thing to remember is that natural log of e to the x is what? Natural log of e is 1. Yes. So what's natural log of e to the x? just x. Okay, now natural log and e are inverse functions, but your crazy calc teacher likes to say, okay, anytime natural log and e are together, they run off together, and whatever's left is what you get. So like natural log and e run off together, there's nothing left, so there's a 1 as a placeholder. But if I had like natural log of e to the 6x squared, natural log and e love each other, and all that's left is 6x squared. Okay, so as long as there's nothing in between them, when I compose inverse functions, I get, so if I had e to the natural log of x, it's still e and natural log love each other, and I'm just left with x. Okay, so anytime e and natural log are right together, they love each other, they run off together, and you're just left with whatever's left. Meaning that if I were to have, excuse me, e to the natural log of x squared, e and natural log love each other, and I'm left with x squared. What if I had e to the 2 natural log x? Okay, do you guys know? Okay, so now here's the problem. Do you see how that 2 is standing in between e and natural log? It's literally getting in the way of their love. So now e and natural log can't run off together until that 2 gets the boot. If we can get the 2 away from the natural log, then we can let e and natural log run off together. So I'm going to use these rules, specifically this one, but backwards. So this exponent really belongs over here. So this is really e to the natural log of x squared again. And now e and natural log love each other, and I'm left with x squared. Okay, so when I say that when natural log and e are right next to each other, they get to run off together. But if there's anything getting in their way, you have to get that sorted out and move it before they can run off together. Okay, you can't not know these rules, guys. You have to, they're going to come up. All right, I want to just go back to this one. Do you guys see how on this one there's no way for me to get natural log and e, just the 2 of them, because the e is grouped with this minus x squared? That's why I couldn't have them run off together. Okay, it's because the e to the x is already in a different relationship. I know I sound ridiculous right now. Okay, but it's memorable. And that's all I need you guys to do is remember things. Okay, so hang on. Why do I want to refresh you guys on those rules? So if I have something like, I have no idea what number I'm on, but if I have, I'm just going to say number 3. If I have natural log of x cubed, I have 2 ways that I can do this problem. Okay, I can do 1 over the stuff times the derivative of the stuff. Right, which I would simplify to be 3x squared over x cubed. Which I would simplify to just be 3 over x. That's really simple. Okay. Option 2 is to realize that this exponent can pop out front. And that means that y is just 3 times the natural log of x. And then I would hold the 3, and the derivative of natural log of x is 1 over x, so my answer is 3 over x. Okay, so I can use those log rules to make some crazy derivatives a lot less crazy. Okay, so if I had y equals the natural log of square root of x, I have two choices. I can do this as y equals 1 over, I'm sorry, the derivative equals, y prime equals 1 over the stuff times the root of the stuff. Now, the root of the stuff is just the root of square root x is 1 over twice the square root x. But then I can simplify that, right? And I have a 1 over, and that's a 2, and square root x times square root x is just x. Okay, or I can rewrite y as natural log of x to the 1/2. And then I could pop the exponent out front, y equals 1/2 times the natural log of x. And then I don't have to do chain rule. It's just a very simple derivative. I have 1/2 times the derivative natural log of x is 1 over x, and these answers are the same. Does anybody have any questions for me? Okay, so most of the time, it doesn't really matter whether or not you choose to simplify these things until you start getting some crazy mother functions. And you will see crazy mother functions on the AP exam. Okay, when you're asked, well, it depends on what kind of AP exam we're going to see this year. I have no idea what kind of AP exam we're going to see this year. But typically, you'll be asked to take the derivative of something like natural log of x cubed times the square root of x squared plus 4. Okay, and the problem with something like this is that the derivative is crazy if I just do it the way it is. I don't want you guys to write this down. I'm going to do it very quickly. My derivative would be 1 over the stuff, and not for nothing, but that stuff is ugly, times the derivative of the stuff needs product rule, so needs a lot of parentheses. I'm going to do first times the derivative of the second. Now the derivative of the second needs chain rule, so I'm going to have to do 1 over twice the square root of the x squared plus 4 times the derivative of x squared plus 4, which is 2x, plus the second x squared, square root of x squared plus 4 times the derivative of the first, which is a 3x squared. And then I got to simplify this crazy mother function. Matt, does this look pretty or ugly? Right, this is very unhappy. Versus rewrite y equals using natural log rules. Okay, so I have things multiplied. That means I'm going to add the natural logs of the pieces. So I'm going to have the natural log of x cubed plus the natural log of, I'm going to write that as x squared plus 4 to the 1/2 power. Do you guys agree that using, oh, this says, I was like, what does this say over here? It says versus. Do you guys agree that these two things are the same using the log rules? Now, why do you think I wrote that as x squared plus 4 to the 1/2 power instead of just square root of x squared plus 4? Because what else can I do? I could turn those exponents into coefficients. So that means I have y equals 3 times the natural log of x plus 1/2 the natural log of x squared plus 4. Do you guys agree that these are all the same using your log rules? And I know you guys don't want to use your log rules, but not for nothing. This is worth, like, this is so terrible that it's worth using your log rules. Okay, now I'm going to go ahead and take the derivative. The derivative of 3 times natural log of x is just 3 over x. Plus, I'm going to hold that 1/2 coefficient. The derivative of natural log of x squared plus 4, I'm going to do a little chain rule here, is going to be 1 over the stuff times the derivative of the stuff. And I'm going to do just the teensiest bit of simplifying. These 2's are going to divide out. And I'm going to end up with 3 over x plus x over x squared plus 4. And first of all, this didn't give me a headache. Second of all, there's not 5,000 opportunities to make mistakes. And third of all, our answer looks way, 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 way better. Okay, so you can use your log rules as a strategy. And this is when I was saying that I want to teach you guys like good life skills. To strategize on how to attack a problem so that it's your quickest, most efficient problem, that's a great life skill to have. That's a very marketable skill. If you're working smarter and faster than your colleagues, you're going to get noticed. Okay, which is why I like talking about strategizing on these. Let's just do one more problem together. I'm going to give you guys a crazy mother function. I'm going to give you guys natural log of square root of x times e to the x over x squared times cosine of x. Okay. So just soaking this up, do you guys recognize that if I just took the derivative of this, I would have to do chain rule on the natural log function. And then I would have to do quotient rule when I go to take the derivative of the inside. And inside each quotient rule, I would have to do a product rule. And does everybody agree that that sounds like the worst deal ever? So in place of that, I'm going to use my log rules to split this up. Now, I tend to split in 1 step or 2 steps. I don't go on crazy. Okay, thank you. Okay, so I'm going to write this as natural log of x to the 1/2 plus, because I'm multiplying it, natural log of e to the x minus, because I'm dividing it, natural log of x squared minus, because I'm dividing it, natural log of cosine of x. Does anybody have an algebra question about why these two things are equivalent? Okay, so again, strategy-wise, I want to simplify this as much as possible so that my work is as simple as possible. So I'm going to drop down this exponent. I'm going to drop down this exponent. This is good the way it is. What can I do with this guy? Natural log and e love each other, don't they? Have I done any calculus yet? Is anything I've done calculus? No, I'm just doing algebra. So I'm going to rewrite this as 1/2 natural log x plus natural log and e love each other, so they're going to run off, and I'm just left with an x there, minus 2 natural log x minus the natural log of cosine of x. And now I'm going to take the derivative. Now we derive. I'm being dramatic. Okay, so this is what I'm looking at. And I'm going to take its derivative. 1/2 natural log x is 1/2 times the derivative of natural log of x, which is just 1 over x, plus the derivative of x is just 1, minus the derivative of 2 times natural log of x is 2 times 1 over x, minus the derivative of natural log of cosine of x. This is the only time I'm actually having to use chain rule. The derivative of natural log cosine x is 1 over the cosine x times the derivative of the cosine x, which is a negative sine of x. And that's my answer.